Our speaker today is Hari, and he's talking about accessible graphics for visually impaired people using touch-based devices.
Thank you. Hello. Is it possible to visualize the structure of our entire human campus just by sitting in this room? The answer is yes. How? With the help of a map. Map is one of the biggest innovations in the field of navigation, and it provides enormous amount of information which has made our lives easier in many ways. But maps are restricted to only a particular set of users still now, and the reason is they are visual in nature, which makes it inaccessible for numerous blind and low vision community. Imagine there is a blind person in this room, and if the person wants to navigate to a room in Little Hall, though it's very close by, even if the person has a map, the person cannot accomplish the navigation task with the help of the map until he can perceive the map. Which brings up the question, how can a blind person perceive a map? This is one of the long-standing questions in the field of blind navigation, and it's still an unanswered one. So my research is based out of this question. So there was a recent survey which stated that with the advent of smart touch-based devices like smartphones and tablets, the blind community, these devices are the dominant device by choice among the blind community. So with this in mind, we thought of providing some intuitive interface that can be a possible solution to address this issue. So our idea is to convert the existing visual graphics of the map and provide them with the help of two other modalities, namely haptics and audio. And we developed the interface with it called the Vibro Audio interface. So we begin our study with understanding what kind of information a map provides visually. So map will have its own map objects, it will have its own attributes, like each of the map objects will have a quantity and it will have a relation with its adjacent map objects. Each of the map objects will have a pattern, it will have a shape, like corridor will be a line, room will be a polygon. And each of the objects will have an orientation with respect to the frame of the map. So these are some of the initial research questions that we wanted to address with such an interface. So we conducted human behavioral study to understand how people can perceive such map objects with the help of haptics and audio. So we conducted three conditions. One is backgraph, letter, and primitive shapes. And in backgraph condition, we provided haptics and audio cues, but in other two conditions, we just provided haptic cues. So the performance in each of the conditions were compared with braille displays, which is considered as gold standard among the blind community. These are some of the sample stimuli that we provided in each of the conditions. And from the results of the bar graph condition, we were able to say that people can understand quantitative and relative information just with the help of haptics and audio. And from the letter condition, we were able to see that people can recognize patterns just with the help of haptics. And from the shape condition, we were able to see that people can remember orientation of an object with reference to its frame. So with our results being significant, we are proceeding further to see how people can do panning and zooming functionality with such an interface. And from the results, we'll extend to see how people will learn a map with Vibro Audio interface. And then we'll compare online and offline navigation with such an interface. And finally, we'll provide a methodology to convert the existing visual graphics into Vibro Audio graphics. So to wrap it up, we believe this interface is an intuitive solution for addressing the existing navigational issue of the blind people, and we believe this is a viable solution to fill up the graphical information gap that is existing between the visual community and non-visual community. Thank you.
All right, thank you.